And at the moment, I'm not seeing the chat. My system is still so sluggish. So are there any questions right at the moment?
Someone asked if we could define the power set.
Define the power set. Okay, well, I'll just start in words, I guess. But for a given set, the definition of the power set is pretty simple. It's really just the set of all subsets of that given set. So given a set A, the power set of A is just the set of all subsets of A. So it always contains the empty set, and it always contains the set A itself. And in general, it contains a whole lot of other subsets that contain, of course, the empty set and are contained in A. Is that the main question? Or, yeah, I'm still finding WebEx is not responding on my laptop, so I'm not seeing the chat properly. Is that the main question, or are there questions about maybe things that were done in recent lectures in connection with the power set, like perhaps you discussed the fact that its cardinality is 2 to the power of the cardinality of the set itself, since you were talking about exponentiation. Again, I still don't see the chat, so if there's been a response, I'll have to ask you to let me know. Oh, I see you're the host now, Alex.
Oh, okay.
Maybe you could start recording the meeting if
It's
that's
already
possible.
recorded. It's already being recorded, I think.
Oh, good. I'm completely in the dark because I'm just seeing a beach ball on my laptop, but I am in touch via my iPad. So let me try to get in better contact, see if I can display the chat here. This is just for question 3. Okay, let me take a look at question 3 then. Power sets, write out the power set given the following sets. Right, so this is really just a matter of applying the definition. For each of these sets, they're all finite sets, so you can simply write out the power set. And it's just a matter of writing out all of the subsets of the given set. So question A, part A, may be a little bit tricky. Note that here we're not saying that X itself is the empty set. X is a set that contains one element, namely the empty set. Unlike the empty set, which has no elements. So in this case, in part A, I think you should find that the power set, well, let's see, I don't know how much I should give away. Go back to the chat. Whoops. Let's see. Do you have any more specific questions about the power set, perhaps with regard to? Muted there. Do you have any more specific questions about the power set and question 3? Or does anyone else have questions about it? Does the power set only contain strict subsets? Oh, sorry. So first of all, I see Jarvis's question. Are these two subsets different? Yes, the first is the set that contains only the element A. The second is another set that only contains a single element, but that element is not A itself, but rather the first subset, that is the set that contains only A, only the element A. So yes, those are different things. Yeah, if null were some object, yes, those would be two different subsets. So this really just goes back to the definition of a set. As sets, those are two different things. And so in the first case, if you're talking about, so those two are included in the power set, well, it depends on the set that you're talking about. Are you referring to a particular part of question 3 now? As long as, put it this way, as long as the set whose power set you're talking about, oh, great, okay. Am I still being heard here?
I can hear you.
Okay, good. I just saw a message that said John Thistle has left the meeting, but I think that's from my laptop. So as long as you're talking about a set that contains both the element A and the set that contains only the element A, then yes, both of those subsets are included in the power set. Again, the power set is just the set of all subsets of the given set. Now, I thought I saw another chat from someone else, or maybe it was one of these messages from Jarvis. Yeah, so you've highlighted some sort of tricky tricky cases that can come up where you have to distinguish between the element A and the set that contains only the element A, for instance.
There is in fact a third option for the null question. There is null with no brackets around it, which would be the set, the empty set.
Okay, if that's what null means, yeah.
I think so.
Oh.
There's like the null with no brackets would be the empty set. Null with one brackets around it would be the set containing only the empty set. And null with two brackets around it would be the set containing one containing one element. That one element is a set. That one element contains one element. That one element is the null set.
Right. Yeah. And so by definition, the empty set is a subset of every set. Therefore, it is always included in the power set. So null would also be included in the power set. Okay. Any other questions? I'm going to try to join again with my laptop.
Anybody else have questions?
Yeah.